Hi, and welcome to this clip looking at some typical Group 7 exam questions from A-level. So the first couple of questions are multiple choice, so we'll take a couple of minutes going through these really quickly. First one asks you which halogen most readily forms 1- ions. Essentially, this is the same as thinking of which one's most reactive, because that's what happens when halogens react. They form 1- ions. So going back to your knowledge from GCSE even, you know that fluorine is more reactive than chlorine, which is more reactive than bromine, which is more reactive than iodine, which means that C is the answer for this one. In the second one, it asks you to consider HBr forming 2 ions in solution, which are obviously H plus and Br minus. When H plus is formed in aqueous solutions, that's the same as any acid, so that means that HBr exhibits acidic behavior because it gives off protons in aqueous solution. And remembering what bromide does, it forms a cream precipitate with silver nitrate, because if we look at the question, it talks about silver nitrate solution in part B. Now, there's a lot of different choices here. Instead of working through each one in turn, what you'll often find is the first one actually tends to match the correct answer. I'm not saying it's always going to be A, but in this particular type of question, where you can't narrow it down necessarily to 2 wrong answers and 2 right answers, you need to think possibly about just looking at each one in turn. So let's look at the first one. It effervesces on addition of sodium carbonate solution. So a little bit of knowledge outside of Group 7 is required here. So if you recall, all acids give off CO2 with carbonates. So that would make sense. So it says which observation is correct. It says observation singular, so that means that only one answer can be right. We happen to have stumbled across that on the first answer. So we don't have to bother with the others because it happens to be A this time. So going on to the next question, it talks about electron configurations of halide ions and asks you to complete the electron configuration of a bromide ion. Now there's a way to do this using the periodic table, unless you can recall. You're not expected to recall what a bromide ion happens to be. You can work it out using the periodic table. So what I suggest is maybe thinking about the rows first of all, those are your periods, and see where bromine is. It's here. So therefore it's on row 4, isn't it? So then you can have a look at the block it's in the P block, and the columns or groups in the P block can be grouped according to P1, P2, P3, P4, and P5. So basically, for example, in this group here, all of the atoms will have their electron configuration ending in P1. This one will have their atoms ending in P2. So obviously, a bromine atom will finish in P5. So it'll actually be 4P5 because it's in period 4. Now, it's an ion we're talking about, so remembering what happens to ions, they form, in the case of halogens, they form 1- ions, so it takes on an extra electron. So the 35 electrons I'm stating there comes from the fact that bromine has 35 protons, so therefore 35 electrons. So the Br- ion must have an extra electron, so it's 36. So it's 4p6 it should end in. So what you do is you work your way through the filling order, S before P, and then you double check, can you add up all of these superscripts, all the little numbers here? So 2 plus 2 makes 4, plus 6 makes 10, then 12, then 18, then 20, then 30, then 6. So we're there. The next part of the question talks about halide ion tests and ion equations. So it says, describe what the student would see in the test tube after the addition of aqueous ammonia. So a small volume of aqueous silver nitrate is added to an aqueous solution of bromide ions. Now in the earlier part of the questions, we happen to have a question about this, so we now know that it's going to be a cream precipitate. The extra bit here is thinking about what happens with aqueous ammonia. So the cream precipitate doesn't dissolve in aqueous ammonia. This is a bit of recall you need to go back and work on. So it's simple recall here, maybe a couple of flashcards about what happens to each of the 3 halide ions. Now the next bit is writing an ionic equation, and they want you to include state symbols. So I'll take you through the technique how to do it down here. So first of all, you draw the full balanced equation about what you're given. Then you draw out the ions. So I've taken AgNO3 and split it into its 2 ions. You then cancel out the spectator ions, and that gives you the final answer. Okay, so hopefully this was a useful quick look through these types of questions. Thanks for listening. Until next time, see you soon.